So I feel like I maybe wasn't as clear as I thought I was yesterday. So let's talk about expectations the night before class when we talk about a new section, and what's expected to do the night before, and then what you're expected to do as soon as you walk into class. Okay? So last night was our first lesson on section 1.1. And so I asked everybody to read the textbook and watch the videos, and then to do the web work orientation to get yourself familiar with the web work system and be prepared for the textbook check when you walk into class. My fault, because I didn't have the times correct on the textbook check. Normally, those are going to happen as soon as you come into class. You should not have access to them at home, because then all you have to do is look in the textbook and answer the question. It is designed to try and encourage you to actually do the work before you get to class. So those textbook checks are worth 5% of your grade. Won't make or break your grade, but the better you do, the better chance you have of maybe getting over a bubble if you are on one at the end of the quarter. So if you do not come in prepared, that is not my problem. You're still going to take the textbook check. You're not going to take the first 15 minutes of class to try and read when you should have done it last night, because our class time is going to be spent actually doing the work that we would normally do as homework so that you can get help. If you spend all your time reading the chapter and then you go home and do homework at night by yourself, that defeats the purpose of what I'm trying to do. Okay? So if you come prepared, take the textbook check, and then I will spend the next 10-15 minutes talking about the material. And after that, I will turn you loose, and you can work on CK12 and web work and ask for help. Okay? So we are starting with section 1.1, where we are defining what real numbers are. This is something that really you would have learned, I don't know, 3rd grade, 4th grade, something like that. But this is just doing a review for you so you can understand how to distinguish between a real number, a rational number, a natural number, a whole number, an integer, and what all of those mean, and be able to categorize those, because that will be something you'll have to do on the ACT, is they'll say, you know, what kind of number is this? And you'll have to know, that's a rational number, that's an irrational number. Well, what's the difference between the two? So even though you may have seen it before, maybe it just hasn't sunk in yet. So we're going to just talk briefly about all of those types of numbers, and then maybe at the end of that discussion, I'll just go around and give each of you a number, and you can tell me what category it would fall under. Okay? All right, so the most restrictive number in the real number system are natural numbers. Who knows what a natural number is? David?
Any number above 1. I mean above 0.
Any number above 0, so 1.3 is natural?
Natural is counting.
Say that again?
Any whole number.
Any whole number above 0. Yeah, you said it's the counting numbers. So what does that mean to you? To me, it means numbers I could actually count physically on my fingers. I can't count 0. I mean, it's hard to count 0 on my fingers. So a natural number is any number I can physically count using digits on my fingers and beyond to infinity. And you're right, it is a whole number, so it's not a decimal, it's not a fraction, it's not a root. It's just a whole number greater than 0, not including 0. Those are your naturals. Okay, so that's our first kind. We're going to talk about the second then. Second after natural, what do you think?
Real.
No? What did you say? Whole. Whole. And if you watch the video, this should be review. Whole numbers. What is the difference between whole numbers and natural numbers?
Whole numbers are like
Because
zero
below
and
0 has 0.
Yep, everybody got it. So whole numbers are natural numbers plus 0. Okay? Still no negatives. Whole numbers are not negative. Natural numbers plus 0. Okay, what's after whole numbers? Yeah, integers. I didn't hear it, sorry. Yes, integers. So integers are all natural numbers, all whole numbers, plus what? Negative numbers. And they're still whole negative. So all the whole numbers turn negative, become your integers. You're still not going to have fractions, decimals, roots, any of that. Okay. So that is integers. What do you think comes after integers? rational. Because rational numbers, I think of rational numbers, if I get confused on this, the first 5 letters of rational numbers spell what? Okay, 4 numbers. No, 5 numbers. 5 letters. 5 letters. Ratio. What is a ratio?
It's like 3 to 5, like 3:5 or
Okay.
1:1.
And another way you could write a ratio is a fraction. Okay? Rational numbers are fractions. That's how I remember rational and fractions. I think of the first 5 letters of rational and remember what a ratio is. So rational numbers, if it's a fraction, it's a rational number. Can 3 be a rational number?
Yeah.
Why?
3/1.
3/1. I can make it a fraction. Right? Any number I can make a fraction, even if it's not written as a fraction, is a rational number. Okay? So that's the next one. And I'm going to run out of circles. Okay, so if it's not rational, what is it? Irrational. It's over here by itself. Okay, so all of these numbers could be considered rational. They're all in that same bubble because I could make them a fraction. Okay, but none of these numbers are considered irrational. So what is the difference between a rational number and an irrational number?
They don't, like irrational numbers don't end.
Irrational numbers don't end.
1,4,1,5,9.
Pi is irrational. Okay? So that means rational numbers do end. Is that what you're saying? Okay? So I want to think on this. I would say irrational numbers don't repeat.
Yeah, they're not.
Oh yeah, irrational numbers are decimals. Numbers that.
Rational numbers are repeating like 0.33333.
Right. So to say it never ends, I mean a rational number, 1/3, never ends because it goes 3 to infinity, right? That last decimal, but it repeats. So an irrational number doesn't repeat and goes on to infinity, like pi. What's another irrational number you can think of?
Square root of 7.
Yeah, square root of 7. Any root that is not a perfect square will be irrational. The square root of 2, the square root of 3, the square root of 4. So don't get it in your head that just because it's got a root in the number that it's automatically irrational. The square root of 4 is not irrational. It's 2, which is not irrational, right? It's finite. Okay? So irrational numbers are pi, square root of 2, square root of 7, the letter E, which we'll learn about this year, but not until next semester. All of these are irrational numbers, okay? So there's kind of 2 subsets under this overwhelming category here of all of it called real. Okay? All of these are considered real numbers.
And then there's imaginary.
Okay? Imaginary numbers, I think it's a bad word. They shouldn't have named it imaginary because they are actually numbers that we do math with. So it's not like they're figments of our imagination. They actually exist. Imaginary numbers do. So the reason they call them imaginary is because they're not in the real subset. So they named them imaginary, and we'll get into imaginary numbers later in this semester. For now, though, we're kind of focusing on real. So let's just throw out some numbers here. Tell me the most specific category it is. So I know they're all real. So if you just tell me that number is real, obviously that number is real. I mean, that's all that we have up there. But I want the most specific category. Okay? So I'm just going to throw a number out, and we'll just start with you.
Oh. Wait, do I have to pick a number or do I have to say?
No, I'm going to tell you a number. 3.7. What's the most specific number?
Wouldn't it be rational?
Yes. It's not an integer, it's not whole, it's not natural. Good. Square root of 9.
Natural.
Yep. Yep. That's the most specific because the square root of 9 is 3, and 3 is a natural number.
So also could be whole?
Yes. If it's natural, it's also whole, an integer, a rational number. If it's natural, it's in all of those, but natural is the most specific subset. Does that make sense? Okay. Let's go over here. 3/4.
Rational.
Rational. Square root of 3.
Irrational.
Irrational. Good. -7.
The integer?
Integer. Good. 73. It is whole, but it's something even more specific than whole. Natural. Because it's positive and greater than 0. Yep. Pi.
It's irrational.
Irrational. 25ths.
Rational.
It is rational, but it's something more specific. It is an integer. It's something more specific. What is 25ths? What's 20 divided by 5?
4.
Okay, so what is 4? It's a natural number. The most specific would be natural. It is all of those that you said, but I'm looking for actually the most specific category. Okay, let's do -6 2/3.
Is it rational?
It is. And finally, square root of 64.
That is
Good.
8.
Good. That's 8. Okay? You kind of get the gist. I mean, in the past, maybe you heard all of these words. Hopefully now you really understand a little better about what all those categories are. Okay. So that's our number system. One of the things in section 2 that we learned to do, if you read section 2 and watched the video, was converting repeating decimals to fractions, which is kind of a cool process. And I don't know, have you done this before? Have you seen it before? Okay. 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 So converting repeating decimals to fractions. Yep. Let me find a problem here. I'll find ones. These are the books if you want to check them out ever. Let's go to some sample problems.
Are negative numbers whole numbers?
No, whole numbers can't be negative. Whole numbers are positive numbers greater than, or 0 or greater. Okay, so in the textbook, this is a number that they gave us for an example. So I'm going to show you the process on how to convert repeating decimals to a fraction. Okay, so first you have to identify that it's repeating. Everybody agree? It's repeating. How many digits does it take to repeat the cycle again? 2. So when you're dealing with decimals, how do I get a decimal to move over 2 places? What do I have to multiply? So you guys are geniuses, right? So what I'm going to do, this is the process. I'm going to let x equal the number. Okay? Then I'm going to move the decimal over until it repeats again. So in this case, I'm going to move it over 2 spots. Okay? When I move it over 2 spots, I get that. But in order to move it over 2 spots, I had to multiply this by 100. Okay, if x is this, if I multiply x by 100, it's going to move the decimal over twice. Now, I'm just going to subtract. This goes away. My decimal's gone. I'm left with 14. 100 minus 1 is 99. Right? 100 minus 1. You with me? And now to solve. Okay? And if I can, I need to simplify. I can't here. So everybody, you don't have a calculator, but let's just do Nicole for us. Would you take 14 and divide it by 99?
It's the same.
It's 0.1414141414 forever.
Mind blown.
I know, mind blown. This is how you convert repeating decimals to fractions. Let's do one more that may be just a little more difficult, because that's what we like to do, difficult problems in math. To find one. Let's do this one, 2.485. Yeah. So we see that it repeats. So we need to move it over 3. So we're going to let x equal this. So we have to go 1,000x equals 2485.485. 485, right? Now I'm just going to subtract. So this becomes 2483. And that goes away. And subtract this, 999. So I'm going to divide. You want to do us the honors again, Nicole? First, let me find out if this can be simplified. Well, I might try 3. Try 2483 divided by 3, see if it goes in evenly. 2483 divided by 3. No. Okay. So another way you can do it on your... It did. Another thing you can do, you probably know this on a calculator, but if I were to take 2483, divide it by 999, you get a decimal, right? Go to
Fraction.
yeah, fraction, and it'll give us the smallest, and so it can't be simplified. Yeah, you guys know how to go to fraction on the calculator? Do you want to learn?
So you have the answer. You have the answer in decimal form, and then you click math, and then it says fraction, and you just press enter, and then
And it converts that
says
decimal to a
answer
fraction. Yep. It will not work on repeating decimals. The repeating decimal is stored in that calculator when she did the fraction. If you just enter, do this, enter 2.485485, and just stop there. And now convert it to a fraction.
It does the same thing.
It gives you the same fraction,
Decimal form.
but is it the same fraction?
What do you mean?
Is it that fraction?
No, it just left it in decimal form.
So when you converted it to fraction, there's no fraction for it. Yeah. So what I'm saying is the calculator only has like 10 digits, 9 digits. So it's not going to have, you can't enter a repeating number in the calculator. So if you're going to try and use the calculator to shortcut this process, it's not going to work. That's my point. You can't just type this number in and tell the calculator that repeats to infinity, figure out the fraction for me. The calculator just knows this number and it thinks it's finite. Okay, so the only way to really get the whole number in the calculator is to take this fraction, divide this by this, and then the calculator stores that whole number. Does that make sense? So you're going to have to do it the hard way, is my point. Okay. Questions on this? Does everybody want to try one real quick on their own to make sure you understand it?
Yes.
Good idea. Okay, I'll give you one. 0.350. Convert this one.
I'm far enough to do it all on my own.
Convert this to a fraction. You not have any paper?
No, I will bring some tomorrow.
Okay.
I promise. No, I'm proving to Thomas that I can do it in my head. Don't judge me if I get it wrong.
multiply it by 10 since to get it for the decimal point for the repeating.
We'll talk about it in a second.
Am I getting wrong?
Everybody have a chance to try it?
Yeah.
Mine has an entire possibility.
Okay, this is kind of a trick question I threw up here because the other two were set up for us to get started right away. This one is not. The way you do this, repeating decimals into a fraction, to the right of the decimal has to be the repeating pattern. Is the repeating pattern to the right of the decimal here?
No, it's not.
No.
Wait, what?
Good answer. So I have to, because 3, 5, 3 never repeats again. The pattern is 5, 0, 5, 0, 5, 0. So the first thing I have to do is get it into that pattern. So I have to multiply it by 10. So I have 10x equals 3.505050. Now I'm going to go ahead and start the process. So I have to move it over 2 times in order for the pattern to repeat. If I move it over 2 times, now I've got my problem.
I literally thought it said 350, 350.
I did too, that's why I married.
Yeah.
And then this becomes 347. So take 347 and divide it by 990.
Wait, 347?
350 minus 3.
Okay.
Should we do another one?
That's
eventually
how it is,
get the hang of it.
347.
Okay, let's do this one, 1.251414. Come on, board. Don't fail me now. 1.2514141414. 1.2514141414. Doesn't matter. They're just, the point is they're repeating.
I think it was 4.
It's an infinite number of 1/4s because it goes on forever. Let's just do that.
Oh, wait. Oh.
You don't think they did it right?
But,
How?
but it doesn't get rid of
It's two
decimals.
repeating numbers, so you can times it by 100. And so,
Did everybody have a chance to try it?
if you times this number by 100, no, if you times this number by 100, you get 1, 2, 3.
So the rule when dealing with repeating decimals is you must start with the repeating pattern to the right of the decimal. Again, this is not starting with the repeating pattern to the right of the decimal. So I have to start there by moving the decimal over twice. So I'm going to start with 100x equals 125.1414. Then I have to move it over 2 more times, right? Because it has to go here now so I can get rid of the decimal. So if I move it over 2 more times, that adds 2 zeros to this. 1, 2, 3, 4. 125.14.14. So there is how I get rid of the decimal.
So that 100x is from when you made it.
Yeah, this is x.
Okay, I see what you do.
And now I moved it over twice so I could start, because I have to have the repeating pattern only to the right of the decimal. So I moved that over. Then I had to move it over 2 more times to get that repeating pattern again.
So is 14 left on this side, or what's left on the right side?
12514 and 125.
So it's 24.
So it's 100. It's 12,514 minus 125. Tell me what it is.
12,889.
889.
No, 389, sorry.
And then this is, what? What's 10,000 minus 100? 9,900, right? $10,000 minus 100. So now divide 12,389 by 9,900.
I just realized I don't understand.
It can't simplify.
Yeah, but what's the decimal?
1.25141414.
What we started with. Okay, I heard a lot of you talking about CK12, so you guys have got the jump start on getting 1-1 CK12 done. Web work, those are the problems that you need to be working on now until the end of the period. I have recorded this, so if you are struggling with repeating decimals and you want to go back and watch some of these examples, I will have it on Canvas tonight, and you can go watch me do these problems again. Stop the video, try it yourself, start it again, watch what I do, and so on. All right?
Is there not going to be any